Okay, brothers and sisters, we have now question number 8. Two masses are connected by a massless string. The hanging mass weight 19.6 newtons. The mass on the table has a mass of half kilogram. The table and the mass have coefficient of friction is 0.18. We need, always in physics we like to draw our problem. We have two masses. This is mass number 1 and this is mass number 2, and we have a string between them. We have weight for this mass, which is 19.6 newtons. We have this mass is half kilogram. We can find its weight, which is half multiplied by g in this direction. We need to know also that we have a tension force in the string. This is tension force, which is the same like this tension force. And we need to look at the question solution. Okay, we have the masses. From this weight we can find that the mass of this object, hanging object, is the weight divided over on g, which is equal to 2 kilograms. In this way we have the weight is equal to the second weight for this object is equal to m multiplied by g, the second mass. The second mass, if we divide it over g, the second mass is equal to weight divided by over g. In this case m2 is equal to 19.6 divided over 9.8, which is equal to 2 kilograms. And the weight for the first object is equal to mass of the first object multiplied by g, which is half kilograms multiplied by g, and the weight for the first object is 4.9 newtons. Okay, now we like to draw the forces acting on the first object. The first one is the mass, the weight downward. This is a free body diagram. We have the normal force upward, and the normal force should be equal to the weight because of third Newton's law. We have the tension force by the string in this case. We have the friction force between the body, the first body, and the surface. The friction force, we have its law is equal to mu, which is the friction coefficient, multiplied by the normal force. Don't look here now. Which is equal to 0.18 multiplied by 4.9, which is the weight, and the friction force in this case is 0.882 newtons in this direction. Now we need to find the acceleration for the second object and for the first object. For the second object, we have the weight downward in this direction. This is the weight, and we have the tension. So the total forces, summation of our forces, is the weight, which is downward, minus the tension, which is in the opposite direction. We can take in this way. In this case, I take the weight in this direction is positive. I can reverse them, but I need to control my own equations. Okay, this will be equal to m multiplied by a, because Newton's second law said that the total forces is equal to mass m2 multiplied by acceleration. Going to the first object, the total forces on the first object is equal to m1, which is the same with which is the mass for the first object, multiplied by the acceleration. The acceleration for both of the for all the system is the same because they are connected by a string. Okay, the forces now, tension force in this direction negative the friction force in this direction. So now I take this direction is positive and this direction is negative. It's okay because I can find everything if I force myself to choose these directions. Okay, now I have two equations. W2 minus T is equal M phi A, and T minus F is equal to M1 multiplied by A. I need just to add them together. 1 plus 2. I need to make it. 1 plus 2 means W2 minus T. This is from 1. Plus T minus F. This is from 2. Is equal to right hand side M2A plus M1A. Now I can cancel T minus T with plus T. So I have the weight for the second object minus the friction force is equal to the acceleration, which is the same. I take it out of this parenthesis, multiplied by the summation of the total masses. Okay. Now I have this last equation. I need to compute the acceleration. The weight for the second object is 19.6. The friction force is this. The acceleration multiplied by half, which is the first body mass. The second body mass, which is 2.5. This is the total forces on the system. They are the external forces, but the tension is internal force. Now I can divide over 2.5 both sides, and the acceleration will be 7.4872 meters per squared second. This is the acceleration. This is the total forces, which are the total external forces. Look here. I have this system. This is the first body. This is the second body. I have external forces will force the system to move, which is weight. I have external forces here, which is the weight for the first body, but I have also the normal force will cancel it. So the weight for the first body and the normal force for the first body, they are external forces, but they are cancelled. Also, I have the friction force, which is external. So the effective forces for the system, external forces, which are causing an acceleration, they are the weight of the second body plus plus the friction on the first body, but the friction in a negative direction of our movement. So we have it with minus sign. So we have the external forces W2 minus the friction force. This will be equal the total system mass, which is M1 plus M2 multiplied by the acceleration. In this case, we compute the acceleration. Now we need to compute the internal forces, if they are exist. Yes, they are exist. We have also the tension force and the tension force here. They are internal forces and they are cancelling each other. Also, we can compute them using any one of our equations. W2 minus the tension force is equal to M2 multiplied by A, or using this one. I think I used the first one. Yes, tension force negative minus the friction force is equal to the first body mass multiplied by the acceleration, which is the same for both of them. I move the friction force to the opposite side, will be and it will be positive. Then the tension force is equal to the mass of the first body multiplied by the acceleration plus the friction force. The tension force will be 2.8 blah blah in newtons. If I compute it using the second equation, it will be the same. Thank you, and see you in next examples.